Good evening, and I welcome you. We are opening up a new chapter, coordination compound students. This chapter is very important. You have come to know already, you have known, we have told you in that chapter of the transition metals student. In the topic of the transition metals, we told you that the transition metal ions form large number of complex compounds. We told you that these metal ions, transition metal ions student, they form large number of complex compounds. Now the question is, what are these complex compounds, students? What are the complex compounds? First question, what are these coordination compounds? What are these complexes, students? In chemistry, you are aware of salts, student. You are aware of the salts. For example, NaCl is a salt, student. Yes or no? KCl is a salt. MgCl2 is a salt. CoCl2 is a salt, student. These are salts. Tell me.
Yes, sir.
If I write palladium chloride, student, or if I write certain CrCl3, what happens when you dissolve these salts in water? You put them in water, what happens? They are ionized. They dissociate completely. Yes or no? It gives sodium and chloride ions in water.
Yes, sir.
And you can test for the chloride ion. How you can test the chloride ion? Add silver nitrate, it will give AgCl. So the ionizable, these are ionizable. What we are saying, they are producing ions, student, in solution. Okay? What is the salt?
Yes, sir.
Salt produces ions in the solution. And what is the valency here? What is the valency here? For example, sodium, you are saying the valency of sodium is only here, oxidation number +1. Sodium valency is 1 here, student. For magnesium, what is magnesium in MgCl2? You are saying 2 plus. Clear? It will dissociate to give Mg2 plus and 2Cl minus. So here the valency is 2, student. And if I say CrCl3, what it will do? It will give 3 plus and 3 minus, students. They are ionized. They are ionized, students. Okay? And here, what we say, this is the idea that they have a valence, student. They have valence. They have a valency, student, which I am talking, it is a primary valency. So there is a primary valency of these compounds. Is it true or not? We can find out how many chloride ions are there in this. We can find out how many chloride ions are there in CrCl3. Can you find out? Because 3Cl, what I'm trying to say, CrCl3, student, in aqueous, what it is giving you? Cr3 plus and 3 chloride ions. So I can precipitate this with AgNO3. How many will be used? 3 moles. You will have got 3 moles of Cl minus. Yes or no?
Yes, sir.
3 moles, and you will need 3 Ag plus. And we can do the conductivity measurements also. What you can do? Conductivity measurement. You have read in the chapter of electrochemistry. Conductivity can tell you how many ions are there in the solution. Conductivity depends on number of ions, student. Yes or no?
Yes, sir.
What it depends? More ions means more conductivity. So we know how many ions, and we know the conductivity value also. We have studied in electrochemistry. Did we tell you? These are salts. Now there are other type of salts, which I am calling, these are simple salts. There are double salts, student. Double salts also in chemistry. Second, this was my first point. What is a double salt? Double salt is that, student, which has more than one salt together. There are compounds which have been prepared, which we know, in which there is no one salt, but there are more than one salt. Double means there are 2 salts. For example, examples of double salt, you know. More salt you are using in chemistry lab? Are you doing titration of more salt? Tell me.
Yes, sir.
What is the formula of more salt, students? What they say? FeSO4 ammonium
dot
sulfate and 6 water molecule.
Okay.
ठीक
Yes,
है?
sir.
Is that right?
Mm-hmm. Yes, sir. Right, sir.
Okay. Shall we make it correction? This is one salt. This is another salt. There are two salts now. How many? Two salts. Do you
Mm-hmm.
see two salts? Like there are methods to prepare double salts. If I will put them in
Okay.
water, again it will be ionized. Again it will be ionized. Now, but how many type of ions will be there? Double means there will be at least more than one cation or one anion. Here there is only one
Uh-huh.
cation. Only one cation. Do you see more than one cation here? No. Here, what cations are there? You will see this is ferrous sulfate, student. Ferrous ion is there. Sulfate ion is there. And
Mm-hmm.
here you have ammonium ions. Do you have ammonium ions? Yes or no?
Yes, sir.
Then this will give sulfate ion. So you have more than one type of cations here. Double salt. Not one cation. There is two type of cations. Or there can be two type of anions.
Mm-hmm.
If I take another double salt, which is carnallite. What is the formula of carnallite, student? KClMgCl2 6H2O. It contains two salts, 1 and 1, 2. When I ionize, put it in water, it will get ionized into potassium ions, chloride ions, magnesium ions. Again, this will give chloride ion. This is aqueous. Aqueous means in water, student. How many cations are there? One or two? How many cations do you see here? Two. This is a different cation. This is a different cation.
Mm-hmm.
These are double salts. Interesting thing is these salts are ionized in water, student. They produce ions. And you can test the ions also. Chloride ions can be tested, student. Sulfate ion can be tested by adding barium chloride. It will give white precipitate of barium sulfate. But there are certain
Mm-hmm.
compounds, students, which are not completely ionized. And as I said, the transition metal ions are forming large number of such compounds, which we call as complexes or coordination compound, students. So this coordination compound is also a salt, a type of double salt. For example, when I write, student, K4FeCN6, student, okay? And if
Yes, sir.
I in the solid or in the solution, it gives me these ions. What ions it is giving, student? 4 minus. Now I have written something in the
Mm-hmm.
bracket. Did I write something in the bracket, student? Tell me. This is in the bracket, this bracket.
Yes, sir.
Now this is not ionized.
He4.
This ion is not going to ionize, students. This does not produce Cn minus ions in the solution. You got only potassium ions and this, but this is not ionized, student. Not ionized. Interesting that these cyanide ions are these.
Mm-hmm.
There are 6 of this. I put 6. Okay? Correction. This 6. These Cn minus ions are not free, student. They are not ionized. They will not give test of Cn minus. That means, student,
Mm-hmm.
these
Yes,
Cn
sir.
are attached, are bonded to the iron. What it means? What it means, student? This is not ionized means what? These Cn ions are, student, forming some bond with the metal ion, which here is iron. Iron, student, bonded with this
Mm-hmm.
Fe2 plus. So there is some bond between Cn and Fe2 plus. That is why they will not be ionized. If bond is not there, what will happen? They will get ionized. They are salts, double salt, students. Such compounds are called, student, coordination compounds. What do you call that, sir? Coordination compounds. Now you see what is the difference.
Mm-hmm.
They have asked this question in the paper, student. What is the difference between a double salt and a coordination compound? It's a question in the paper, student. Note it down. What
Yes, sir.
difference, student, between this is also a type of double salt because it has two cations. See, potassium ion and iron, there are two cations in it. In these double salts also there are two cations. right? So what is the difference then between
Yes, sir.
double salt and complex salt, student, or coordination compound? This question was asked. Now, what is your answer? What is your answer? I've already explained to you everything. What answer you are giving, student? Double salt is completely ionized, but
Yes, sir.
coordination compounds like this or complexes, they are not completely ionized. They are ionized only to this extent, which I have shown. But this FeCN6 4 minus is not ionized. Therefore, there is some definite bond between these cyanide ions and iron ions. This is called coordinate covalent bond. This is called coordinate covalent bond, student. So complex ions do not dissociate completely, whereas double salts will dissociate to completely and will give you test of those ions are there. That will be used in order to find inference of these coordination compounds. Therefore, first thing is that we have understood that there is a different type of double salt, students, which are not completely ionized in solid or in aqueous solution. And we are saying these are formed mostly by transition metal ions. Which are the transition metal ions? You already know: chromium, cobalt, iron, manganese. All these transition metals, you know. We have given you a complete list in 3D series, students. So many: copper, nickel, all this. And we are saying there is some molecules, students, which are we are calling as ligands. They are forming some bond with these metal ions. And that is why they
Yes,
cannot
sir.
be ionized. And we represent them in the brackets, this bracket. See the bracket? This entity cannot be dissociated, student. This is non-ionizable. This is non-ionizable, student, the entity which I have written. So such compounds are called coordination compounds, students. And we will see how it was discovered. Who is the father of the coordination chemistry, student? We are going to see that. Why are we studying this? You will ask me, students. Because these compounds are very important, student. And they are very, very important compounds because they have biological as well as other applications, students. You know, chlorophyll. Chlorophyll is also a complex compound, student, is a coordination compound. And chlorophyll has got magnesium. Magnesium is a coordination compound of magnesium. Hemoglobin is a coordination compound of iron, student. You know, ham, you have heard about ham, student, it has iron. Vitamin B12.
Yes, sir.
Vitamin B12 contains cobalt, students. Cobalt. They are also complex compounds. And in metallurgy, student, they are used for extraction of the metals like silver and gold. They are extracted from their ores by complex formation, by complex compound formation, students. And industrial also, they are used
Yes,
as
sir.
analytic reagents, and they are also finding uses in electroplating, medicinal chemistry, and textile. Certain coordination compounds are used for removing poisons from our body. Now, what about lead poisoning? So certain compounds are used to remove these poisonous lead from our body, students. Even for treatment of cancer, cisplatin is being used. These are coordination compounds. Therefore, we are interested to study them. Okay, you have noted down all this? Then I will proceed further.
Yes, sir.
Okay. So students, the person, the scientist who discovered coordination compound is Werner. Who discovered it? Werner, student. Werner, student. He is the father of coordination compound. How did Werner discover, student, coordination compounds? First point. Question number 2. What is the Werner's theory of coordination compound? Werner's first question. What is the Werner's theory of coordination compounds, students. One question is usually given on this in the exams. So we are going to give examples of that. Actually, as I told you, if I have COCl3 student, it dissociates to give CO3
Yes, sir.
plus and 3Cl minus. Okay, no problem. And
Mm-hmm.
valency, I'm saying this is a primary valency is 3. 3 ionizable anions it gives. But Werner was studying student, he was
Yes, sir.
preparing some compounds of COCl3 or CrCl3 student with ammonia. But he was doing that series of compounds of cobalt 3 chloride. Series of compounds
Okay.
of cobalt 3 chloride with ammonia was being prepared. With ammonia. Important point.
Yes, sir.
Okay? You have cobalt 3 chloride solution. You add
Yes, sir.
ammonia in different amounts. In different amounts.
Amount.
And it was found when he added student different amounts of the ammonia, he was able to get not one compound, but different compounds of different colors. And when he tried
Okay.
to precipitate the chloride ions present in them, he found that different moles of chloride ions were precipitated by these compounds. And the compounds had
Yes, sir.
different colors. Student compounds has different colors. So what I am trying to say that you have COCl3. You are adding student in this ammonia. Okay? Ammonia. You are adding ammonia, solution of ammonia student.
Yes,
What
sir.
was the result of that? That they were able to get student, as you have seen, yellow,
Hmm.
purple, green, and violet. You are getting not one, but different compounds.
Yes, sir.
How do you say they are different compounds? First thing, the color is different.
Hmm.
If a color is different, that means it is a different compound, students. And second important point was
Yes, sir.
that only some of the chloride ions could be precipitated. Only some of the Cl minus could be precipitated, student, by silver nitrate. By silver nitrate will form what? AgCl. What it shows,
Hmm.
students? What it shows that it was done in cold, student, in under cold condition. What it proves, student? What it proves that, for example, if I have here, I have written 1 mole of COCl3 6NH3. It was found that this is yellow in color. What is the color? Yellow. And it gave 3 mole of, it produced 3 mole of AgCl. That means there are 3 mole of Cl minus ionizable. How much? Ionizable. How many moles of Cl ionizable? 3 moles. Because 3 mole of AgCl is produced.
Yes, sir.
Another compound was COCl3 5NH3. Now, in this, when they did experiment, student Werner was doing all this. He found it was giving 2 mole of AgCl. What it means, student? That there are 2 Cl minus ionizable number of chloride ion
Hmm.
is how many? 2 Cl minus. Actually, you
Yes,
have
sir.
3, but ionizable only 2. What it shows? What it shows, student? That at least 1 Cl is still attached to the cobalt. That which is not ionized is still bonded to the cobalt. Yes or no? If it is not bonded
Yes,
to
sir.
cobalt, then it will be ionized and it will give test of the chloride ion, or it will be precipitated by silver nitrate. One of the Cl is not precipitated here, and color is different, purple. Further, he found another compound COCl3 4NH3. It was green in color and it gave only 1 mole AgCl. But it proves that there is only one ionizable Cl many ionizable Cl, how many? 1 mole. That will give 1 mole of AgCl. Where are the rest two? They are still bonded with the cobalt. That means third one, what he found, again gave a 1 mole of AgCl. Third one again gave 1 mole of AgCl, but the color is different. This is violet, this is green. That means they are some type of isomers. These two are giving only 1 mole of AgCl, but color is different. That means they are different compounds. They must be isomers. They must be isomers. Therefore, student, these are the observations of Werner student. Question is, what
Yes,
observations of the Werner proved that there is a complex compound formation, or there is a, instead of one type of valency, there are two types of the valencies. Instead of one valency, there are two types of the valencies. That is the theory of the Werner's theory of coordination compound. Werner observation, one observation, you can see the what he is trying to do, student. He is precipitating, what he is precipitating? Chloride ions. ठीक है? By
yes, sir.
silver nitrate. Silver nitrate will produce Ag plus, and Ag plus will react with Cl minus to produce AgCl. ठीक है?
Yes, sir.
If there are 2 Cl, then you will need 2 Ag plus. If there are 3, you will need 3 Ag plus. Like this, he was doing these observations. Then he, second thing, student, he was studying, was there, what he was studying, student, conductivity measurements in solution. Second thing, he studied the conductivity measurements in solution, student. Conductivity measurement will give what result? It will tell us how many ions are present in the solution. Number of ions present in the solution, student. Okay? We already know.
Yes, sir.
The conductivity depends on the number of ions. And on that basis, student, he said that in these compounds, some, not all the Cl minus are ionizable. That means some chloride ions could be precipitated as AgCl on adding excess silver nitrate, but some remained in the solution. Therefore, we can say, student, that this Cl minus which we are having, there are two types of that. One is ionizable and other is non-ionizable, students.
Yes, sir.
And non-ionizable must be, these non-ionizable must be bonded with the cobalt. If they are forming some type of bond with the cobalt, student, then they cannot be ionized. If they are not forming bond, they will be ionized. They will be ionized. So, therefore, students, it was suggested. What he suggested then? This is another class of compound, platinum, ammonia, where we are showing the conductivity measurement. First, let me tell you.
Yes, sir.
Now, on this basis, student, on this basis, what he suggested, he said that this compound is producing 3 mole of AgCl. How much? 3 mole of AgCl. Let me make some space. You have noted down this?
Okay. Yes, sir.
Note down. And he made the conductivity measurements to find out the number of ions in the solution. Number of ions in the solution. Student, who was doing it? Werner. Werner was doing all these experiments, student. On the basis of experiments, he will give some results. Let us see what is he trying to do. We are going to discuss Werner's theory of coordination compounds. Okay, let me change the color of the students. On the basis of this, there are 3 mole of AgCl. There means there are 3 Cl minus which are ionizable. And on that basis, he wrote the formula like this: CONH3 6. I am putting brackets here, student. 3 plus, and how many ionizable? 3Cl minus. If I write this compound which is yellow in color by this, what it means, student? How many chlorides are ionizable here? 3. This is 3. And for this, which was purple in color, only 2 AgCl is obtained. So what he is giving, student, to this compound, he wrote COClNH3 5, student. Then it is 2 plus and 2Cl minus. 2Cl minus. Okay? This will produce how many AgCl? 2 moles of AgCl. This will give you 2 mole of AgCl. This will give you how much? 3 mole of AgCl. If I will add silver nitrate. Clear?
Yes, sir.
This compound is purple in color. This is yellow in color. Then another one, only one Cl is there. So he is saying the 2 are still inside. And NH3 4, student. Then this is plus and this is minus. Okay? It will give how many mole of AgCl? 1 mole of AgCl. Same is, this will also be like this, but it is a isomer of this, which we will explain in the coming lectures. Okay?
Yes, sir.
This will also give 1 mole of AgCl. Because there is one ionizable here. That means there are 2 types of valencies now, student. Ionizable and non-ionizable. This Cl, that means this Cl is attached to the cobalt, student. Is bonded to the cobalt, which we call as a coordinate covalent bond. But I will show you the picture of that.
Yes, sir.
Coordinate covalent bond, student, is being found between these, which we are writing in the square bracket. The square bracket is a coordination entity, student. These Cl are non-ionizable, these are ionizable. 2 types of valencies now. Primary valency, and then he called this as a secondary valency, which are directly bonded to the metal ion. They are the secondary valencies. This is the primary valency. And how many ions will be there in the first case? Tell me. How many ions are there? In the first case, how many number of ions if I calculate? Okay, let me erase it. This you have noted down. Let me also see how many ions are there in each case, student. How many ions will be there? Tell me. If I will do the conductivity measurements will tell me what the number of ions. Okay?
Yes, sir.
Conductivity measurements are done to find the number of ions. Okay? And on what he did further, because at that time, whatever things were available, student, he was doing it. Now we are measuring conductivities. You know, in electrochemistry, conductivity depends on the number of ions, student. Conductivity was measured. Conductivity, how many ions are there? 1 plus 3, 4 ions are there only. You see 3 chloride ions and 1.
Yes, sir.
You are having, what type of electrolyte is this? This is 1:3 electrolyte. And total, how many ions? 1 plus 3, 4. Conductivity will be called. In this case, how many ions? 2 plus 1, 3. That is 1:2 type of electrolyte. How many ions? 3 ions. Here, how many ions? 1 plus 1. This is 1:1 electrolyte. And total 2 ions.
Yes, sir.
Here also 1:1 electrolyte, student. 1:1. And total ions 2. So from conductivity values will be different. So he measured the conductivity values. And therefore, what he concluded, student, what he concluded. This is a Werner, this work is done by Werner, student. And on that basis, he gave his Werner's theory of coordination compounds. Werner's theory of coordination compounds, students. Let me take another example. These are the complexes of platinum. And experimentally, number of ions observed was 5 in first case, 4, 3, 2 by conductivity measurement, and unit of Cl minus, in this case 4, Cl minus precipitated, 3 precipitated, 2 precipitated, 1, in this case 0 chloride ion. No Cl was there. Conductivity values
Yes,
are
sir.
also there. This is experimental information, student. Experimental information data. ठीक है? These are the platinum complexes.
Yes, sir.
5 ions mean what, student? 5 ions are produced. That means you are having platinum NH3 6. If I have this compound, student, Cl4, what? How many ions will it will produce? Tell me. If I ionize this, what will happen? Platinum NH3 6. This is 4 minus. Then this will become 4 plus. ठीक है?
Yes, sir.
How many ions? 4 ions are these. 1 ion of this. Total number of ions 5. So conductivity here, number of ions 5, student. Conductivity value Mohs inverse. You know, Mohs is the unit of conductivity, ohm inverse. 523. They measured it. Here the value 404 means there are 4 ions in the solution. 4 ions in the solution are there, student. So what it shows, what it is showing, student, that it will be looking something like this. Platinum. Then you have, student, in this, how many ammonia are there? 5. And there is 1 Cl inside. And then how many are outside? 3. So in this case, only 3 AgCl will be, 3 silver ions, mole of silver will be used. That when this Cl is different from this Cl. This Cl is bonded to platinum, student. This is not bonded to platinum. This is ionizable. Tell me. And
Yes,
this
sir.
Cl is non-ionizable. Clear? So there are 2 types of,
Yes, sir.
there are metals have 2 different kinds of valence now. One is called the primary valence, other is called the secondary valence. Secondary valence is those which are bound with the metal ion directly. These are the secondary valence, student, and the ones which are ionized, they are called the primary valence, student, which is the oxidation state of the metal.
Yes, sir.
So these experiments done by whom? Werner. And on that basis,
Yes, sir.
Student, on the basis of the following observation made with aqueous solution, assign, before that, this is a question. So on this basis, student, on this basis, Werner proposed his theory. What is that theory? What is the theory which was given by Werner's? Werner's, they are also known as Werner's postulates or Werner's theory. So the question is, what is Werner's theory of coordination compound? This is the first theory which was given. Werner said that in coordination compound, there are 2 types of valencies. There are 2 types of linkages or valencies. How many types? 2 types.
2 types.
Those which are bonded with the platinum and those which are not bonded. They are ionizable, they are non-ionizable. So he said primary valencies are, one is called the primary valency. And primary valencies are ionizable. Ionizable means that they are ionized, student. In this case, in this case, the primary valencies are ionizable. These are ionizable 4. The primary valency is 4 plus here, 4. Primary valency is 4, student, ionizable and satisfied by what? Negative ions. Negative ions.
Yes, sir.
So in this case, if I write this compound, if I say this compound, in this, what is the primary valency, student? Platinum. What is the primary valency of platinum? 4. This is being how many ionizable counter ions? 4 negative ions. That is the primary valency. This is
Yes,
the
sir.
primary valency. Here is, you can see how much ionizable Cl minus 4. And he says there is a secondary valency. Two types of valency, primary and secondary valency, student. What is the secondary valency, student? This is equal to student. What he says, the secondary valency are the groups which are bound to the metal ions. Equal to student, ions or groups bound to the metal ions. Metal ion, student, which is also called the coordination number. Coordination number, student. They are forming, student, a coordinate covalent bond with the metal ion. Okay? They are bound with this. For example, if I write this compound, student, platinum, in this case, what do you find? This, if I say this compound, PTNH3 5Cl, what it mean, student? If I say PTNH3 5Cl, if I write like this, student, this is 3 plus charge. Okay? 3
Mhm.
3. These are
Yes, sir.
bound to the platinum, student. They are bound to the platinum. How? By a definite special arrangement also. How much you have?
Mhm. Okay.
NH3, 5 NH3 and
Yes,
1
sir.
Cl and 1 Cl. They are forming coordinate covalent bond with the platinum. And there is a
Okay.
definite special arrangement. There is a definite special arrangement. So secondary valency is equal to coordination number and is fixed for a metal. This is called coordination number and is fixed for a metal, students, for a metal. And what is the next point in this? That the ions or groups bound to, by the secondary valency, what we are saying, ions or groups, students, bound to metal ions. Metal ions. What are they called? Secondary valencies.
Yes, sir.
By the secondary valencies have definite spatial arrangement. Have definite spatial arrangement. They have definite arrangement around the metal, octahedron, tetrahedron,
Mhm.
square planar. These type of
Yes, sir.
geometries will be there, and we are representing them in the square brackets. In the square brackets, students. So, students, Werner theory proposed two valencies are there, not one valence. In ordinary salt or compound, you have only one valency, which is the primary valency. Here we are saying primary valency is that which is satisfied by the ionizable negative ions. Okay? And secondary valency is that in
Yes, sir.
which these groups or species are attached or bonded to the metal, bonded to the metal ions. That was proposed by whom? Werner. On what basis?
Yes, sir.
Experiments. Which experiment? He precipitated the chloride ions by silver nitrate. Then he measured the conductivity measurement. Two things were there. Not, no
Yes, sir.
apparatus was really. Now he says, on the basis of the following observation made with aqueous solution, assign secondary valencies to the metals in the following compounds. Question. This is a question now.
Yes, sir.
The following observation in aqueous solution. What I said, one is a primary valency, according to Werner, and second is secondary valency, student, or secondary linkages. These are those which are bonded with the metal ion and are written in the square brackets. They will not be precipitated. In the first case,
Yes, sir.
For example, question number 1, student, what is the formula? PdCl2 4NH3. ठीक है? And how
Yes,
many
sir.
moles of AgCl per mole of the compound? He added silver nitrate, and how many moles of Ag? 2 mole of AgCl is obtained.
Yes, sir.
Then you have to answer what is the secondary valency here. What are the, how many groups are attached to the central metal? What is your answer? You have 1 minute, 1 minute to answer the question, students. You have 1 minute to answer the question.
Yes, sir.
What is the answer? Question is, what is the secondary valency in this compound?
I'm answering, sir.
What it means? These Cl2 are ionizable. 2
Yes,
Cl
sir.
minus 1 ionizable. And only you will get 2 AgCl. That means the compound looks like something like this. Cl2. Right or wrong?
Yes, sir.
So with the palladium, there are, how many groups are attached with the palladium here? 4.
Yes, sir.
And with the palladium, you have how many groups? 4 NH3.
Yes, sir.
So what is the secondary valency here then? What is the secondary valency? How many groups are attached? 4. So
Yes, sir.
secondary valency 4 here. Got it? In this compound. First one. In second, what is the formula of the second? NiCl2 6H2O. How many Cl minus ionizable? 2. Then you will get 2 mole of AgCl. How many is given? 2. So what will be the formula then? And what is the answer? NiCl2 6H2O. What is the secondary valency here, student? What will be the secondary valency here? Tell me. How many ionizable Cl minus 2? So it will be H2O 6, student, and Cl2, right?
Yes, sir.
So how many are attached to the nickel here?
Okay.
How many are attached to the nickel? Tell me. This nickel is attached to, student. How many? H2O. This is OH2O, OH2O, OH2, H2 means OH2. And 6 are attached, student. How many? 6. These are not ionizable. Secondary valencies. Then secondary valencies.
Yes, sir.
6. What is the answer then? 6. Here secondary valency will be how much? 6, student. Clear?
Yes, sir.
Okay. This answer been done. Third question. Third question says, student, in the third, what is the formula given? PtCl4 2HCl. And how many ionizable? Cl minus 0. 0 AgCl. What it means then? What is the then what is the secondary valency? Find the secondary valency, student. What is your answer? What is the secondary valency here, students?
I'm 6.
6 is the right answer. That means this is something, all these are inside the coordination sphere. They are present inside the. So you can say that it is, you are having, what is this looks like? PtCl4 HCl twice, student, and they are inside the coordination sphere. So 4 and plus 2, 4 plus 2, 6. They are called the ligands. These are called the ligands, student. We will explain to you in the coming class. Ligands are those which are donating lone pair of electrons, and metal ions are those which are accepting the lone pair of electrons. That a coordination compound is formed. And what is happening here, student, in the next fourth? COCl3 4NH3.
Okay.
Here there is only one Cl minus. See, 1. So what
Yes,
is
sir.
the formula of that? What will be the secondary valence in this case, student? Secondary valency you have to write.
Okay.
What is the secondary valency in this case, student? Only one Cl minus is outside. So you are saying it is something like this.
Yes, sir.
Cl. How many groups are bonded to the cobalt? How many atoms are bonded to the cobalt by coordinate covalent bond, student? How many? 4 ammonia
Yes,
and
sir.
Cl.
Hmm.
So total becomes 6. Secondary valence is 6. Secondary valence is 6 here. It is, you can say something like this, student. There are NH3, NH3, because there is a definite special arrangement as is shown by the Werner. Like this, they are bonded to the cobalt, student. And that is free. This one is free. That free is outside. So how do you represent, student, for example? I can say, student,
Yes, sir.
what I'm trying to show. देखो, you have this entity plus
Hmm.
and this Cl minus free. This is ionizable. How many? Only one. So these are the secondary valencies and these are the primary valencies. Primary valencies are primary valencies. We have already told you, student. They are equal to the what is being in the primary valency. They are satisfied by the negative ions or anions. They are satisfied with the anions. So in this case, student, this secondary valency, how many groups are bonded to the cobalt? 6. So secondary valency is 6. The last one, PtCl2 2NH3, 0 Cl. This is 0. This is PtCl2 2NH3. Then what will be the secondary valency here, student? What is the secondary valency in this compound? This is the last one, 5th. What is the answer? 5th answer. How many groups are bonded to platinum?
Okay. Yes, sir.
2 and 2, 4. So the secondary valency is 4. Clear?
Okay. Yes, sir. Clear, sir. Now it's clear. Now it's clear.
Therefore, student, this is the first lecture. We will continue more about this in the next lecture tomorrow. We will meet you at 12 o'clock to continue further about this coordination compound. So this is the first theory, which I have told you is Werner's coordination theory. The Werner's coordination theory is all about this. There are two types of valencies. One is primary, other is secondary. Secondaries are those which are bonded to the metal ion, and primary are being balanced by the ionizable counter ions, negative counter ions. Clear?
Yes, sir.
And how did he observe all this? By precipitation with silver nitrate and also by conductivity measurement. Only two things were there at that time. Okay, then good night. Then I will see you in the next class. Tomorrow 12. Okay? Clear?
Yes, sir.
Okay.
Yes, sir.
Okay, then good night.
Okay. Thank you, sir.